After we create a new milling project and select the stock and coordinate system, we now need to choose the tools that we will be using. After looking at our model, we choose our first tool size of 10 millimeters. We then create a second tool with 14 millimeter size diameter. We now select our third tool with a 25 millimeter diameter. This tool will be able to remove large amounts of material at once. We then need a drill bit with a ball nose. We will leave the dimensions of this one the same. Now that we've completed making our tools, we can start the milling operations. First, we start with a 3D milling. We need to define our geometry. We do that by defining the working area. As you can see, I select this face and it creates the working area. Next, we need to select our tool. We go to the list of the tools that we made previously, select the 14 millimeter drill bit. Next, we need to select the levels that we'll be milling. First, we select the upper level. This will be the highest point on the stock material. Then, we need to select the lower level. The lower level will be the face that we defined earlier in the working area. Then, we need to select the technology. For this operation, we'll be using contouring. We can then calculate and simulate that operation. Next, we create another 3D milling operation. Once again, we define the working area. This time, it's inside the slot. We now need to select the tool again. Due to the small area between the cylinders and the slot, we need a very small tool. For this one, we'll be using a tool with a 2.5 millimeter diameter. Once again, we need to select the upper and lower levels. Once again, the upper level is the top of the stock block, and the lower level is the bottom of the slot. We also need to select the technology again, and once again, we'll be using contouring. As before, we can now calculate and simulate this operation. As can be seen from this simulation, the tool did not go between the cylinders and the inner side of the slot. To fix this, I went back and edited the operation and changed it so that it left 0 millimeters between the edge of the wall and the edge of the tool bit. This allowed the tool bit to move through that small area. Next, I needed to mill the spherical shapes. I started by doing the one on the left first. By using the ball nose, I was able to successfully do this. Next, I created a drilling operation. I defined the working area as the 2 holes that we would be drilling. Next, I selected my 10mm tool. For the levels, the upper level was the flat surface the holes begin on, and the lower level was the bottom of the workpiece. I now needed to mill the spherical shape on the right hand side. I used the ball nose drill bit again and repeated a similar process to the left one. I then calculated and simulated this to make sure that I had done it successfully. Next, I created another 3D milling operation. I needed to mill that slot down so that it would be at the correct height. I repeated similar processes to the previous times, where I define the working area, select the tool, select the levels, and choose my technology. Once I'd completed all the operations, I calculated all of the operations, and then I was able to generate the G-code. Next was the brake disc. As before, I created a new milling operation. I selected my machine, defined the stock block, and define the coordinate system. Once I had done this, I needed to create my tools. First was a standard end mill. This one had a diameter of 25mm. This would allow for fast removal of large amounts of material. Next was a 10mm end mill. This would allow me to drill the holes which would hold the brake rotor in place on the car. Then I created a 6mm end mill. This would allow me to drill the holes, which would create the holes in the brake disc. Then I created a T-slot end mill, which would allow me to drill the slot around the edge of the disc. Now we need to start adding our operations. The first operation is a 3D milling operation. First, I define the working area. I select the innermost edge and the outermost edge between which the area will be milled. Next, I select the tool piece. I'll be using the 25mm diameter tool piece to remove large amounts of material. Next, I select the levels. The top level will be the upper piece of the stock material, and the lower level will be that face I just selected there. For technology, we use contouring. I now need to add another milling operation. I repeat the same process where I define the working area, select a tool, and select the levels. This time, the level will be between the upper level will be the same as the lower level as the previous operation, and the lower level will be the main face of the disc. I now add the third operation. This third operation mills out the material in the center of the disc. All three of the previous operations used the 25mm drill bit, which means we didn't have to change the drill bit between those operations. Now we do though. We are now drilling the 5 10mm holes, which is how we secure the brake disc onto the car. We select the holes individually for the working area. We then select our tool and our levels. The upper level being the face of the brace disc where the holes start, and the lower level being the back side of the brake disc. Now we need to drill the holes which make this a slotted brake disc. We have to individually select each of the 60 holes. Once we've done that, we confirm that this is our working area. Next we select our tool. From the list, we select the 6mm tool. Then we select the levels. Once again, this is the face of the brake disc for the upper, and for the lower, the back side of the brake disc. Once this operation is complete, we can calculate all and generate G code. Then we need to create a new milling operation for the back side of the brake disc. The clamping position is changed from being vices on the side to being clamped on the inner surface of the brake disc, which protrudes outwards. This will allow us to profile mill around the outside edge of the brake disc, as well as the T-slot, we select our stock material and define our coordinate system. This time, you can see the axis starts in the bottom of the brake disc with the Z direction pointing upwards on our screen. Now, we need to begin creating our operations. Our tools will be the same as last time. For this first operation, we create a drilling operation and use a 15mm drill bit. We select the 5 holes and drill down to a level to a depth of 5mm. We use the same drill bit to now mill the inner slot of that large hole. Next, we need to profile mill around the outside edge of the disc. Once again, we can use the 15mm drill bit for this. By using this drill bit, it reduces the amount of time the machining takes, as we do not have to change the drill bit between operations. Next, we need to drill the inner T-slot. We define the working area by clicking on the inside lower edge of the slot. We then select our tool, which is the specialized T-slot drill bit. For the levels, we select the ceiling as the top side of the slot, and then specify a depth of 5mm. We then check our geometry. As we can see here, the drill bit is moving through the inside of the piece, so we switch the geometry from the left to the right. As you can see from the simulation, the drill bit enters, moves around the outside of the disc, and then out. This leaves a slot through the disc. Now that we have completed these operations, we can calculate all the operations and generate our G code.